If you visit the BitConf landing page, you probably notice this 3D puzzle trying to resolve itself on the top of the page. And you might wonder, how did they build that? But then you go down and you see that there is a code button that if you click, it opens an editor with all the code involved in the creation of this 3D puzzle and its resolve. So you can program yourself the resolver here and try to solve the puzzle. You can also see the Trust.js components of the pyramid and the scene itself. And you might wonder, how in the world did they build that? That's what I'm here for today, because I'm going to explain you how the BitConf pyramid 3D puzzle was created and built. A love story between Trust.js and web containers. But before we do that, my name is Álvaro Sabu. I'm a developer experience engineer at Storyblok and also a content creator. I'm the author of Trust.js, which is the library that we're going to use today to create the 3D puzzle. You can find me in all my networks with @AlvaroSabu, and you can always say hi. So, how everything started. One day, I was chilling on Discord, and I received a message from Patek, aka Matias, and he told me like, hey, sorry that is in Spanish, I'm gonna translate it. Will you have some minutes for a call? Yes, I'm just free. I'm in the airport, and I have something interesting for you for the BitConf to talk about. Ooh. So we have a half an hour call in the airport before Patek got into his plane. And the conversation went something like this. Hey, can we build a 3D pyramids puzzle with the BitConf logo? Oh, sure, it's totally doable. I gotta admit, I had no idea how to build it in that moment. But challenge accepted. First, we needed to think about what in the earth is a pyramid, because in that point of time, I didn't know even that exists. So a pyramid is a regular, I'm gonna read it. It's a regular tetrahedron puzzle that is similar to the Rubik Cube, but instead of a cube, you have this pyramid kind of thing. So basically the pyramid version of the Rubik Cube. So we went to the first step, that was the design. So in this phase, we had two options. We could download a pre-existing 3D model of the pyramids puzzle and just try to make it work with the rotations, or we could create two different models for the two principal pieces and then replicate them. We went for the second option. So we decided to create one octahedron, which is this one, and one tetrahedron. So the pyramid itself is made of 10 of these, which are the ones with 4 faces, and 4 octahedron pieces, which are the 8-faced geometry. So the next step was to build the puzzle itself in the 3D scene. And for that, we're gonna use Trust.js. So Trust.js is a Vue custom renderer that allows you to create 3D experiences as you were using Vue components and composables in a declarative fashion. The way you can install it is by using pnpm or your package manager of choice, add Trust.js core, and you have to install tree as a pure dependency. If you want TypeScript support, you install the types from tree. Then we create the wrapper or experience.vue. This is the Vue component that is going to contain the Trust canvas. So we import the Trust canvas from the core package, and then we add it to the template. Here I am also adding the suspense wrapper for the pyramids. Why a suspense wrapper? Because we are going to do an asynchronous operation in the pyramids to load the pieces inside, so we need to wrap it with a suspense. The next step is going to load the individual pieces. So to do that, we're going to use a composable called useGLTF that is available on the Trust.js CentOS package. Think of this package as the Vue use of Trust.js. So once we import it, we can use it passing the URL where the location of the 3D model is, and then it's going to return the nodes and the materials of the corresponding model. We're going to do the same for the octahedron. And then in the pyramids.vue component, we're going to iterate through an array of tetrahedron that we're going to see in the next slide. And for each one of them, we're going to pass the position. and we're gonna pass the model. This is because we want to avoid creating new models whenever we are iterating. Instead of that, we're using the same model for all of them. Same thing for the octaedron. This is how the tetrahedron array looks like. We're creating a ref and we're using a utility to center all the objects in the scene, okay, just translating the position. And inside of it, we're defining the position of each one of the different pieces because we needed to calculate where are located in the space. We also added some metadata that are the groups, and we're gonna see what the groups are about. This is a preliminary photo that I sent to Patek at the beginning with all the different groups and meshes created in the start. Then let's talk about the rotation, which was probably the most difficult part of all. So this is how the rotation groups of the Pyramix puzzle looks like. And I know it's kind of difficult to understand, so I'm gonna try to explain it as much as possible. So we have different groups. We have the L groups, which are this triangle here, and then L prime, which is just the tip of this side. Then we have the same notation for the upper group. So the upper group is all this pyramid in the top, and the prime one is just the tip. Same for the back part and the right part. So this is kind of difficult because I actually have the puzzle here. The rotation was tricky because as different as the Rubik Cube, this one can rotate like this. So it's an inclined rotation. As you can see, like here, this one is easy. But then if you go to the sides, it starts to be more complicated. So rotating the pieces in the correct motion was complicated. This was one of the first attempts that I did, and you can probably notice why it's so wrong. Okay? Then a lot of math was involved, and I needed to learn new concepts that I didn't know before. So for the inclining rotations, what we end up doing is that, as I explained before, the pyramid puzzle is not structured like the traditional cubic one. So the rotation axis, where the thing is rotating, is different from the standard 90 degrees of the cube. So here we needed to define all the different rotation axes, and they're conformed by vectors. Okay, the vectors is the representation of the orientation and the magnitude of the axis. So in this case, we have the U1, which is the simplest one because it's just one in the y-axis, but the L1 and the R1, I just calculated manually, okay? And then we have the concept of the angle of rotation. So this puzzle works like this and like this, meaning that it can go clockwise or anti-clockwise. The angle of rotation for this movement to maintain the same figure is 2 multiplied by pi divided by 3. And if it's clockwise, it's a negative fashion, okay? So we needed to calculate the angle, and we pass it to the function if we wanted to do the movement clockwise or anti-clockwise. And then we add in the angle. Then we needed to grab all the objects of that group. That was the metadata that we included in the array. And then we use the axis map that we see before to get the rotation axis. Then we needed to calculate the centroid. The centroid is just basically this dot right here, which is the centroid of all the groups. Okay, so we calculated for each group where the center of all the objects was to do the rotation from them. And here we're going to use something called quaternions, which is something quite complex to explain. But what we are doing here is calculating the quaternion using the axis angle. So we're using the rotation axis and the angle that we calculated before. And then we are multiplying it, like we are multiplying the objects by that quaternion. And what are quaternions? This is quite complex to explain, so I'm going to try to do it as simple as possible. Quaternions are a type of math that is used mostly to make easy the rotations in 3D software, okay, to calculate the rotations, because it doesn't have the same problems as Euler angles. If you want to research about it, feel free to search it because it's a complex topic. So to animate the rotation, what we did was creating a function for animation and request animation frame to do one of these every frame per second, okay? And the reason we get the incremental is that we need to calculate the current quaternion and then pass the new quaternion with a slurp. So this is a linear interpolation, but in this case, it's special for quaternions. So we are basically saying how much we're quantifying the animation between one quaternion and the next quaternion, okay? Then we needed to calculate like the time of the animation, and then we set the rotation from the quaternion to affect all the objects that are on that group. And we're setting it to the current quaternion. Then we're calling the request animation frame to run again. This is the result of the animation. So this was without the colors, and you can already see like how it rotates with the rotation axis. But there was an issue with that, and the problem was the consecutive rotations. Whenever we were rotating the pieces, the rotation axis changed. So the pieces now are belonging to a new group. And when that new group rotates, they go off, and the colors went wrong. So the way we fixed it was actually creating temporary groups instead of just adding the objects directly and rotate them. We were creating groups, like 3S groups, and then copy the position from the centroid and adding them to the scene. So then we're taking all the objects from the pyramid reference, and we were removing them from the pyramid and add them to the temporary group. Once we have it in the temporary group, we set the rotation from quaternion like we did before, and then do the animation, and after it, we get all the children of the temporary group and we remove them from it and add it again to the pyramid. So that way, we managed to create something like this. We were rotating all the different groups consecutive, and everything was working correctly. Once we had our 3D puzzle working and optimized, the next thing we tackled was the web container integration part. And this is probably the most interesting part of the whole experience because we managed to embed a 3D puzzle into a web page with web containers and an editor, so you can actually edit the JavaScript that is running on this puzzle to complete the solving part, and you can modify it and try to solve it yourself. So how that was done? So the landing page first loads the Tres.js pyramid as a view component, okay? When you click the code button, what it basically do is it runs or configures a web container with the dev server to run the pyramid code as it was in a repository. The way you can set it up is pretty straightforward. You have the instance of the web container, and then you boot it with your name, so whatever your code is, and then you mount it with certain parameters. Then you can modify, or like you can set up the editor as you want. You can add the theme that you want to use. This is using Xterm and CodeMirror, okay? So we have a function that allows us to set up the whole thing, and we pass the web container instance that we just created. Then we can install the dependencies. So we use one method of the WC, which is the spawn, and then we are using as a package manager pnpm, and we are telling it, hey, install with this command. Then we're exiting the process, and then we just start the server. Okay. This is going to add the URL into the iframe where you see the pyramid moving around. Of course, there is more to it. So we recompile some tricks and tips that we learned in the process that will help you create a similar experience like this one. So the first one is that you can integrate the iframe for the web container with a transparent background. So the idea of having the transparent canvas and the smooth transition between the original view component and the new one inside of the dev server, it gives it like a seamless experience that is actually the same component when it is not. Then you can pass the key press whenever you're using the keyboard to modify, like solving the puzzle. You can pass them to the parent window, to the iframe once the server is running on the pyramid. So you can transmit the messages up. We needed to implement like a custom hot model replacement to avoid reloading when the user was changing the salt.js. So we were using import meta hot asset under the hood. And to speed up the start time, because we are talking about 3D and this could delay or affect the performance of the page, the way of doing it was zipping, like creating or mounting two files. One, it was a zip with all the source code and everything that we needed, like all the node modules pre-installed, and then a script to unzip it and load it. So we completely skipped the installation process of the whole thing. It was already installed, and I think this is something that the SvelteKit tutorial team made it possible, so thanks for the trick. And also don't forget to configure the course in your Vite app. And with that, we can talk about the learnings of the whole experience. So as a takeaway, you can use Tres.js to build immersive 3D experiences on your websites declaratively by using Vue components. You can also integrate it with web containers to run a Vite dev server in the browser tab. We can simply integrate an editor and a functional 3D scene in the same page and allow the user to modify the 3D scene. Projects are way more fun when they are done with friends. And last but not least, the web is amazing and is full of potential. Imagine all the cool projects that you can build after seeing this integration. I want to thank all the contributors of Tres.js. Without them, this package wouldn't exist and wouldn't be possible to do with Vue. Thanks to our sponsors. I'm happy to see this list grow. So thank you to everyone that has contributed financially to the project in the last months. If you want to help us, at least with the coffee, because coffee runs our machines, please do it in the same link on sponsors GitHubs or in GitHub sponsors or in Open Collective. And thank you very much. See you in the next one. Ciao, ciao.